Good morning. This video is on the law of cosines, which in a way is similar to the law of sines. And the way that it's similar is that it allows you to find a missing side length or missing angle of a non-right triangle. So when I look at this particular triangle right here, I notice that it is a non-right triangle. There's no right angle. There are three sides, and all of the sides are lowercase letters. So typically what we use is we use lowercase letters to represent side lengths, and we use uppercase letters to represent angles. Law of cosines can be used when you're given all three sides and you're looking for one of the angles. It can also be used when you're given two sides and looking for an included angle. So for example, if you're given side C and side B and angle A, then you can potentially find this side over here, which would be A, and so on and so forth. So we'll use it in a couple of different ways in this video, but the idea is that you're either looking for an angle or a side length. When you're looking for a side length, you're going to be using just the regular cosine function. When you're looking for an angle, you're going to have to take the inverse at the end, and I'll show that in the examples. Now, there's a very basic pattern that works with the law of cosines, and I'll start with the first one, which is this equation right here. So what you'll notice is that it starts out a squared. Okay, so if we're looking for side A, we start out the equation a squared. It's equal to b squared plus c squared, so the other two sides squared and added together, minus 2bc, and you'll notice that b and c are squared here. They also happen to be multiplied here. And then it gets multiplied by the cosine of capital angle A, which you'll notice that it starts with lowercase a and it ends with capital A. So the pattern is whatever letter it starts with, it's the other two sides squared minus 2 times those two sides times the cosine of the angle of that same letter that you started with. So for the second one, b squared is equal to a squared plus c squared minus 2ac. So notice how the a and the c also get plugged in here, times the cosine of angle B, which is B, what we started with. Okay, so this is angle B, this is side length B. So if you were to venture a guess as to what C squared would be, okay, C squared would be very similar, it'd follow the similar pattern. So we would say that C squared equals the other two letters squared. So if I go ABC, it would be A squared plus B squared. Okay, so that takes care of ABC, minus 2. So notice how there's always a 2. There's a 2 here, there's a 2 here, there's going to be a 2 in this equation. The two letters that are right here are A and B, so it's going to be AB. And that is all multiplied. So these three things are multiplied. So the 2, the A, and the B are multiplied. And you would multiply by the cosine of the angle of the same letter that we started with. So because we're starting with lowercase c, we end with capital C, which is angle C. So you will notice that that is right here. And that would be your third equation. Now, we don't necessarily have to have the A's, the B's, and the C's, but it allows you to see a pattern when we find the missing side length that we're looking for. So in example A, we are looking for side length X. In example B, we're looking for an angle, so we're going to have to use an inverse. C, we're looking for an angle, so we're going to have to use an inverse. F is we're looking for an angle theta, so we need to use an inverse. E, we're looking for a side length, so we will not have to use an inverse. And then D is looking for a side length, so we won't have to use an inverse. So what I'm going to do is I'm going to go over a few of these just so that you have an idea of what to do. I'll set up an equation and we'll talk about how to solve it. It's going to be really important that you have a calculator and that you're following along with this, or you're putting this into your notes just so that you have it. And just by you following along, you're going to learn how to type it into your calculator. And it's going to be very important that you do that, because if you don't, you're going to get really behind when you have to do it on your own. Okay? Do this with me so that when it's your turn to do it, you've done it a few times and you get that practice. So for the first one, we are looking for side length X. So the way that I am going to start my equation is I'm going to start my equation as x squared. Okay? So whatever side I'm looking for, I'm always going to start with that squared. Then what I'm going to do is I'm going to take the two other sides that are given and I'm going to square both of them and add them together as part of that equation that we saw above. So if I scroll up here, we notice that it's the other two sides squared and added together. So the two sides would be 17 and 22. So it would be 17 squared plus 22 squared. Okay, and this is the part that follows the pattern. Minus, this is the part where three things get multiplied. So I have a 2. I have side 17, so times 17 times 22 times the cosine of the angle that is across from the side that we're looking for. So because we're looking for side x, that's across from the 42-degree angle, so we're going to use the cosine of 42 degrees. Now, what I'm going to do is I'm going to grab my calculator and I'm going to type it in exactly like I see it right here. So I'm going to type in, I'm going to start with just a cleared screen, okay, a blank screen, and I'm going to take 17 squared plus 22 squared. So I just typed that in. So 17 squared plus 22 squared minus 2 times 17 times 22 times the cosine of 42. I typed it in exactly like I see it right here, step by step, number by number, and I end up getting x squared equals 217 point, so let's type this in, 217.128. Okay. Now you can round this to 1/3 or whatever you need to do, but that's kind of the idea behind that. Then I notice that that gives me x squared. But if I look at these side lengths, we've talked about this before with triangle inequality. The absolute most that this side can be is adding these two other sides together. So 17 plus 22, which is 39. The absolute most that this could be is like 38.99999, just under 39. So 217 is clearly too much, but 217.128 represents x squared. So what I'm going to do is I'm going to take that 217.128 and I'm going to take the square root of that. So I'm going to take square root of 217.128, and that gives me approximately, so this is an approximate answer, x is approximately 14.735, so approximately 14, excuse me, 0.74. Okay. And we know also by triangle inequality that the absolute lowest that this side could be is 5, because 22 minus 17 is 5. So my answer has to be somewhere between 5 and, we said, 39. So 14 is definitely within that range. Okay, so 14.74 definitely seems reasonable. Now, that's an example of one where we are looking for a side length. Okay. The next one we're going to be doing is looking for an angle. So we're going to do letter B, and we're going to look for an angle. And the way that we do that is we start it very similar, but we need to know where the angle is. And the angle is across from the 35. So what we're going to do is we're going to use that 35 as our starting number, kind of like we used x squared as our starting variable. Okay. So we're going to start this one, and I'll do this one in red. Okay. We're going to start this one with 35 squared. Okay, so I'm going to do this up above here. So 35 squared equals, and then the other two sides are 39 and 47, and it doesn't matter the order that you do them in. So I'm going to say equals 39 squared plus 47 squared minus 2 times 39 times 47 times the cosine of theta, which is what we're looking for. So in this case, we don't know what theta is because it is what we're looking for. First thing I'm going to do is I'm going to figure out some of these values. So I'm going to figure out that 35 squared is 1,225. Okay, so if I take 35 squared, it's 1,225. Okay, then I'm going to take 39 squared. So 39 squared is 1,521. Okay, then I'm going to take 47 squared. So 47 squared is 2,209. Okay, minus, okay, so I notice that there's a minus. And then I'm going to multiply these three numbers together. So I'm going to take 2 times 39 times 47, and that gives me 3,666. And then that gets multiplied by the cosine of theta. So just to kind of touch on what we just did here, just so that we're on the same page and we know what's going on, 35 squared is 1225, 39 squared is 1521, 47 squared is 2209. Here's your minus symbol. 2 times 39 times 47 is 3,666, and then multiplied by the cosine of theta. And since we don't have a theta measurement yet, we can't really do anything with it. Okay. The next thing that we're going to do is we're going to take these two and add them together. So we're going to take 1521 and we're going to add 2209, 3730. Hello? Hey, what's up? I don't think so. I think it's good. Yeah, he'll be fine. Yeah, he's doing great. Yeah, no problem. All right. Yeah, bye. All right. Sorry about that. All right. So now what we are going to do is we are going to take this 3730 and we are going to subtract it over to the left-hand side. We're going to subtract it from the 1225. Okay. So what I did was I took these two and I added them together and I got 3730. So I'm going to subtract 3730 from both sides of the equation. So 1225 minus 3730. Okay, so grab my calculator, 1225 minus 3730, which gives me negative 2505. Okay, and that is equal to, let's go over to this right-hand side. I do have this negative here that's in front of the 3666. So it would be a negative 3666, and this number is always going to be negative, times the cosine of theta. Okay. The next thing I'm going to do is I'm going to recognize that negative 3666 is connected to the cosine of theta by multiplication. The inverse of multiplication is division. So I'm going to take both sides and I'm going to divide by negative 3666. Okay. So I'm going to take the negative 2505 and divide it by negative 3,666. Now, it isn't always true that both of these are negative, but I would say quite often that happens. So when you take these two negatives and divide them, two negatives divided is a positive, and it's going to be a decimal, and that's going to be equal to the cosine of theta. So if I take negative 2505 and I divide it by a negative 3666, I end up getting, and I'm going to go to 4 decimal places, I end up getting 0.6833. Okay, 6833. And that is equal to what's left over here, which is just simply the cosine of theta. I've mentioned this multiple times, but anytime you're looking for angle theta, and it's connected to this cosine, so when you're saying cosine of theta, the way to get theta by itself is to take the inverse. So what you are going to do ultimately here is take the cosine inverse, okay, cosine to the minus 1, cosine inverse of 0.6833, and that is going to give you angle theta. So I'm going to go second cosine inverse, 0.6833, and that gives me an angle theta of approximately 46.897, so 46.90 degrees. Okay, so my theta, angle theta, is 46.90 degrees. So that would be the answer for part B here for finding theta. Now, it's definitely more work to find the angle, but the reason why it's more work is because ultimately in the end you have to take the inverse, and it's just kind of an extra step. But I would definitely say that finding the side length is quicker. Okay, if I had to pick which one takes less time. So I'm going to go ahead and clear this. So far we've done one where we find a side and one of them where we find an angle. So I'm going to go ahead and clear the ink from the page. And let's look at another one where we're looking for an angle just because we just did it and it's kind of fresh in your mind. And we can go ahead and do letter C just because it's the next one in order. So we did A and B. So if we go to letter C, we'll do this one. And again, we're looking for angle theta, and angle theta is across from the 13. So I'll do this one a little bit quicker in terms of the setup, but it's very similar to the other one. It is going to be 13 squared is equal to, and then it doesn't matter if you do 7 or 9.4 first. So 13 squared equals 7 squared plus 9.4 squared, okay, minus, same pattern as always, there's always a 2, times the 7, which is the first number here. Then that gets multiplied by the 9.4, which is the second number. And then that gets multiplied by the cosine of theta, which is what we're looking for is angle theta. Okay, so this is using the law of cosines because we have the cosine here. So I'm actually going to combine a couple of steps here in one. I'm going to take this 7 squared and I'm going to subtract it over, and I'm going to take 9.4 squared and I'm going to subtract it over right away. So what I'm doing is I'm taking this 13 squared and I'm going to type that in right away, and then I'm going to subtract 7 squared and I'm going to subtract 9.4 squared, and I'm going to move it all over to one side. So basically I'm dumping all of this over to this side by subtracting it. So I'm going to grab my calculator. I have it cleared. I'm going to take 13 squared, which is this side, and then I'm going to subtract 7 squared, so minus 7 squared, minus a 9.4 squared. And what that gives me is it gives me a positive 31.64. Okay, so I end up getting 31.64 equals, and now that I've taken care of moving these over right away, which is just something that you can do to save some time, I now need to multiply these three numbers together. So if I take a negative 2, okay, notice how it is a negative, right? Negative 2 times 7 times 9.4, I end up getting a negative 131.6, and then that is still being multiplied by the cosine of theta. So notice how I'm saving a little bit of time and a little bit less work just by subtracting those two parts over right away. Okay. The next thing I need to do is get cosine of theta by itself. It is connected by multiplication. The inverse of multiplication is division. So I'm going to divide both sides by negative 131.6. Okay, so that side gets divided. This side also gets divided by negative 131.6. So a positive divided by a negative is a negative. So this is going to be a negative number. So 31.64 divided by a negative 131.6, and you end up getting negative 0. And I like to go to 4 decimal places. I guess it's just a personal preference. 24042. So 2404. And that is equal to what's left, which is just simply the cosine of theta. Again, I've mentioned this before, but I'll say it again. Anytime you're looking for angle theta, you're typically going to use an inverse. So I'm going to do the inverse cosine. So cosine inverse in order to isolate the theta by itself. So cosine inverse of negative 0.2404. And whatever that is in my calculator, that'll give me an approximate theta value. So I'm going to grab my calculator and I'm going to type in second cosine inverse negative 0.2404 and I end up getting an angle theta that is approximately, and before we even look at it, we would say that this angle definitely looks like it's more than 90. Okay, I would say that it's an obtuse angle, so it's reasonable that it would be over 90 degrees. Theta is approximately 103.91 degrees. Okay, so that's another example of one where you're looking for an angle. And then last but not least, I'm going to show you one more example where you're looking for a side, because we haven't done that since we did the first one. And then that leaves one side and one angle for E and F for you to try on your own. So I'm going to go ahead and clear the ink from the page just so that we can kind of start fresh on letter D here. Because we're looking for a side length, which we're looking for x is across from 47 degrees, we're going to start with x squared. And by now you probably know the pattern. X squared equals, and then you do the other two sides that are given to you, and it doesn't matter the order. So I can do 23 squared plus 20 squared. Some people always like to take the smaller one first and the larger one second. It really doesn't matter. Okay, minus, there's always a 2, times 23 times 20 times the cosine. In this case, we do have the angle, and the angle is 47 degrees. Okay. And now what I'm going to do is exactly like I see it here is how I'm going to type it into my calculator. So I want to find x squared, because eventually I'm going to find x by taking the square root, but I don't need to do that right now. X squared equals, and I'm going to type it in exactly like I see it, number for number, operation by operation. So 23 squared plus 20 squared minus 2 times 23 times 20 times the cosine of 47. And that gives me approximately 301.561, so 0.56. So that gives me x squared, but I don't want x squared, I want x. So in order to find x, I would have to take the square root, which means I'm also going to have to take the square root of this. So if I take the square root, second square root of 301.56, I end up getting an approximate value. So this is approximate, not equal. Approximately 17.37. It's 365. So 17.365 or 37. And again, using triangle inequality, I would say that if I take 23 minus 20, that's 3. And if I take 23 plus 20, that would be 43. So my answer has to be somewhere between 3 and 43, and 17 definitely falls within that range. So 17 seems very reasonable for x. So now you can try E and F on your own. For this one, you're just going to basically do it similar to what we see here. And then for this one, you're going to be using an inverse at the end. Make sure that angle theta is across from 4.9. So it's going to start out as 4.9. Oops, that's a big 9. Squared equals. Okay, and then it's other side squared and other side squared. So I'll let you figure that out.